I am Linda Cele, holding BSc Electrical Engineering and also a registered professional engineer with Engineering Council of South Africa. I work at GIP Engineering and Architect. I am a business development manager for power and energy sector. It quite forms, I would say it forms a backbone of the economies in Africa, basically because if you look at the economies, they basically have three stages, or they've got three tiers. You've got economies that are resource-based, you've got economies that are efficiency-based, you've got also economies that are driven by innovation. And if you look through all of them, you will deduce the fact that the better the infrastructure, the economy is able to translate, or rather to move from one stage to another. The economies that are based on innovation, they've got the healthiest electrical infrastructure. As well as if you compare the economies that are efficiency driven compared to those that are resource based, you'll realize again that the efficiency driven ones, they've got a better infrastructure compared to the other one. So from that analysis, one can then conclude, or rather one can realize that electricity plays the big role in the economy. The other reality also is the fact that now the world has become the global village, and we compete with everyone in the world. Whether you are in Africa or you are in Asia, it really doesn't matter. The fact of the matter is we're competing on the same clients. So for us to be able to have competitive edge, the issue of price, of the selling price cannot be ignored. So with high volumes, you are able to compete in terms of the price. And one of the biggest influences around having more volumes is the electricity. Without electricity, you will not be able to produce volumes that would be produced by a person who's got a healthy infrastructure. The biggest challenge that we have in Africa is to be able to, is the ability to deliver the actual equipment on site due to different reasons. It could be the issues of terrain, it could be the issues, the historical issues, it could be that probably the road infrastructure still needs an upgrade. But the bottom line is that if you look at Africa as a whole, it requires electricity to be able to address all the other infrastructure issues. Let me give you an example. If you are to put up a road in a country where you really lack road network infrastructure, it wouldn't be good for you just to do the gravel road, because that will be more of an access road. The tar that you will put on that road, on the road, it will be less costly if it's produced in the country. But you can't produce tar without electricity. If you look at to attract investors in a country, the investors will be interested in the health state of a particular country. We can't talk hospital without talking water. But to reticulate water again, you need electricity to pump water to different from the source to the point of consumption. So one can acknowledge that electricity forms the backbone of any form of improvement, and in the economy as well as on the developing side of other forms of infrastructure. It involves a lot of planning. I think the operative function is basically planning. You find areas where you don't have roads at all, but you will find, if you've planned correctly, you might be able to find proper trucks that can be able to drive on vegetation just to be able to get the infrastructure or the typically equipment like your transformers and the circuit breakers onto the point of your destination. The other issue as well is to make sure that you have a local partner, because a person an indigenous person in the country will have a better knowledge than you if you're coming from outside the country to say, if you want to move from point A to point B, the best route to take will be a particular route. So the planning part can involve a couple. It could be trucks, it could be tractors that will be required, it could be airlifting of equipment to a point of destination. It could also involve even overhead wheeling of equipment. So it really depends on the planning that you have put in place before the day of execution. They do, provided they were consulted in time. Remember that the OEM, in as much as he is involved in the project, it depends what scope did you give him. If you involved him on a level of just supplying the equipment, that's what you will get out of him. But if you involve him to an extent that he checks the route for you and he recommends the appropriate packaging that will talk to the terrain, that will talk to the logistics or the transporting logistics of the equipment, then you'll be able to have more value out of your OEM. But if you don't involve him to that extent, you can buy a piece of equipment from Europe only to use it in South Africa, even though you are based in Angola. So really, the OEM heavily depends on the person who buys the equipment to give him more details as to what is it exactly the equipment will be used for and where will it be used for. And if possible, you can even take him to site and show him exactly what the site looks like so that he can be able to package the whole thing for you properly. Yeah. Let me start by saying every project that we engage on, it's on the backdrop of a contract that would have been signed between the service provider or the consultant, being us in this case, as well as the client or the consumer of the product that we would have designed. And the main objective is to address the needs of the clients. And the basic thing is that if we look at different services, so the services that will be rendered, it basically depends on what is required, the type of the product. So if we're looking at electrical engineering, we're looking at the science and applied science of basically addressing the needs of the electricity for consumption purposes. So it could be on a distribution level, it could be on a transmission level, it could be on the building services level. It really depends what is the client that is actually looking for. It's quite an interesting one, master planning, because it talks to forecasting. It's not necessarily looking at what is currently in place at that particular time, but it involves the current and the future. And it's quite critical because it guides the clients as to what is it that they need to do in order to meet their futuristic goals. If we were to take, for an example, at looking at a municipality, if a municipality wants to put together a master plan, we'll have to consider things like what is their estimated population growth, what is their estimated industrial growth, basically what is their IDP of that particular municipality. As well as we have to look at non-technical issues around electricity. we're looking at the available land that can be used for to basically mount the infrastructure or to house the electrical infrastructure. We look at the social impact assessment that can be due to the laying of the infrastructure. We look at the vegetation. There could be different protected plants. There could be different protected species like type of animals. So the master plan basically takes all that into account, such that when the infrastructure construction is implemented, it's implemented in a way that brings the balance between the futuristic goals as well as the capital investment that needs to be put down, as well as the impact on social matters. Definitely. They are. In fact, in a sense that if you look at a master plan, we will be putting a plan to grow an existing system. So it will be critical to take into account that the client has got an existing workforce that has been trained to operate equipment of a particular type and of a particular technology, not necessarily the brand, but the actual equipment, and also to take into account what is the thought pattern of the OEMs, because that needs to be taken into account if we do the planning. So in order for us to be able to plan, to put down a plan that will yield return on investment, we have to make sure that the client will have the capacity to adapt to the new, to the growth that will be implemented. We have to look into the availability of skills to a certain extent, to say if we implement, if we say we propose that 10 substations be built in 1 year, will they have enough capacity to maintain those? Because if they don't have the capacity to maintain, then it becomes a problem, because it becomes white elephants. Again, we look into the realities, that what type of equipment that they have, because that will speak to their stock of spares. We don't want to come up with a plan that will propose a complete different change to the existing items or type of equipment that they're using, because it will mean that they'll have to keep different types of spares. And it will mean also that they need to go back and retrain their staff in order to be able to operate. So basically, a master plan that cannot provide sustainability becomes a problem. And sustainability will be a function of the capability of maintenance and also to operate. Yeah. That is also a function of the contract. Most of the clients would prefer that they own the actual master plan. It becomes theirs, and in that way they receive you as a service provider who will be reimbursed for the service that you provide to them. But should it happen that the contract is such that the master plan is your own property, then that will be also accepted, provided it's agreed upon. There is a reality that we need to accept, though, that skills transfer is relative to the capacity that is already existing to an individual. It will be unrealistic to expect someone who has never received any form of training that I give a skills transfer, for example, of programming a relay. But the reality is that, again, a person who has never been trained on electrical skills, I can be able probably to give him a skills around trenching, for example, which is relatively easier to read and to understand rather than trying to program something else. So, but going back to your question, the fact is, if we do not have trained people in the close proximity of the infrastructure, makes the running cost of the infrastructure to increase, because you will need someone to drive a couple of kilometers who will be driving away from the actual infrastructure, or you'll need someone to fly in, and that will actually create more cost for you to basically run your equipment or your system. Failure to that, you'll find the actual infrastructure falling into pieces, and then that will basically result into capital expenditure that really does not yield any returns. And most of the time, these infrastructure will be put up by the governments, and the people will really will not appreciate that coming from the level of the government. So it's quite a critical thing that when infrastructure is put up, proper skills transfer be put into place, and if possible, have redundant system in terms of availability of skills, because as human beings we do not know what future holds for us. So you might find that someone relocates to another country or to another area, and you don't want then to try and retrain someone under such pressures. Our operations are sustainable. We are guided by different laws in different countries, and it's quite important that for every electrical engineer recognize that the electrical infrastructure is not all about the electrical design, but we do have other side effects that can be as a result of your design. So what the good practice is to involve an appropriate team, put together an appropriate team before you actually do your design. So that will involve your environmental scientist, who will look at the route that has been selected or the position that has been selected to place your infrastructure. We'll look at heritage sites along the route. Are there any heritage sites? We'll look along the route, are there any areas that probably are used by the community for their own benefit? And we also look at natural resources, areas of natural resources, like are we probably having on the route, are we having a river, are we having wetlands? And then we engage the community through public participation forums to make sure that the position and the land that has been secured is the land that is available, and everyone, we've got a buy-in of everyone. So once that is done, then we can be able then to start and to plan, or to do the actual design of the infrastructure. But before that, it is not appropriate to just see an open land and then think that it could be used for the electrical infrastructure. In fact, for any infrastructure for that matter. Yeah. Construction monitoring, it's quite also a very critical aspect of a project, because it actually meant to enforce, or rather also to evaluate progressively the compliance of construction to that of the design. It, it, it ought also to be carried out by someone who is well experienced as well as well qualified. We need to be able to translate what you see on site to what you see on paper and compare the two. Then if the realities on the ground forces that there be changed that needs to be made on the design, then that needs to be marked on the design. In other words, you take your design and you just put on a red line to show that the as is on site now is on this position, because that is basically fed back to the client at the end of the day to say, this is what on site. So if you go on site, this is exactly what you'll be seeing. So it's quite critical. But the other thing that is also important is that it is also informed by the contract as well as the complexity of the project. The EXA guideline currently talks to three types of construction monitoring. We've got level 1, which is suggested to be once in 2 weeks, and we've got level 2, which is also the EXA guideline proposes that an agreement of frequency to site be agreed between the service provider and the client, and the third level will be the full time. So it means the clerk of works needs to be on site every day. But what is also of key importance is that there should be reports that are coming from the construction monitoring. Methodology for construction monitoring should be clearly spelled at the beginning. What is it that is expected from the construction monitoring exercise? What reports is the client expecting, so that gives the reference to the work that will be carried out. But besides that, it's just another tick box exercise, which may end up costing either the client a lot of money or the service provider himself. People, they will appreciate electricity when they make use of it at their homes or probably their workplaces. But the reality of the matter is that electricity is generated at a far distance from the consumption point. And the link between the two will be your transmission system as well as your distribution system. The transmission system is basically all about ensuring that the distance between your generation point and your distribution point is such that the losses are minimized. So with transmission system, we relatively have high voltages. In South Africa, we've got it's 400 kV. We've got 275 kilovolts as well, which will form your transmission system. For very long distances, we use DC your DC voltages, because that also has got an improved losses relative to the length of the line. But then again, once the electricity has been transmitted to a point of distribution, it's not yet suitable to be consumed by our appliances. Then we need a distribution system that will basically distribute electricity from the point that of delivery from the transmission system to our different consumption points. It could be homes, could be offices, it could be the factories, and that also will inform the voltage level as to what voltage level needs to be there. In South Africa, under distribution, we've got 132 kV, 88 kilovolts. We do have 2211 kV. In other areas, we still do have 33 kV. And then at our homes, we're looking at 230 volts. Yeah. The biggest challenge in designing a transmission line is the availability of the servitude lines, the servitude land, because your infrastructure needs to run in a reserved area, which will be owned by the utility. And you might find that a feasible area, a feasible land to run your line is probably owned by a certain community, which will find it difficult amongst them to reach an agreement to give the land away for different reasons. So that's one challenge. The second challenge is that, see, in South Africa, people, they get to own the land. And in as much as the land can be open, but if it's owned by an individual, it's also a challenge even to trace that particular person. Because you might find that maybe with the Surveyor General, the land is registered under someone, but if you engage that particular individual, you realize that the land has been transferred to someone else, either through procurement or whatever reason that it could be. So it's quite, to secure the land is the biggest challenge, because once the servitude is known, then you will be able to identify the form of terrain, and then you'll be able to put the best design solution to address that terrain. Once the land is available, then everything should be relatively easy to do after that. Once the environmental impact assessment has been concluded, then it also will then go to the point of GIS, so it's Geographical Information Systems, which basically will show us, probably it runs parallel to EIAs, to Environmental Impact Assessment, but basically we look into what is it that is found on the route and what is it that we want to avoid. For example, we can, on our system, be able to dictate that we want to avoid dolomite areas, we want to avoid river crossings, we want to avoid probably slopey terrains. It really depends what is it that we want to avoid. So, or rather to minimize. Then we put it into system, and then we look again, relook into the route, and if the route is fine, then that will be perfect. And once the route has been established, to say now we agree that this is the route that we'll be taking, then we do what we call a geotech study. We look at specific points, especially the points where the line bend, we call them bends. We look at least at those points at a minimum to see what type of soil is actually going to be is found on those GPS points. Then on the basis of the soil, we will then be able to design an appropriate foundation for your structures. But the type of material that will be used on your structures is informed by different things. It will be looking at the conditions of the weather conditions, prevailing weather conditions in that particular area. We'll be looking whether is it inland or is it coastal. We'll be looking at things like your bird life and stuff like that. So basically addressing any concerns from the environmental impact assessment studies. And we're also looking at the spans between your pylons. That will also inform the type of the material that needs to be used. And from there, then we basically, to make sure, or rather to improve our our way of doing things, what we know, what we employ. There's a tool called the PLS CAD that we're currently employing, that we feed the tool with all the information that we would have collected on site, and from the geographical information system study, and from there we are able then to simulate the actual line and see whether will it be able to hold or not. Once we find the line to be feasible in as far as the mechanical aspect of it is concerned, then we further simulate it again using Dixalan to look at the properties now of electrical properties, to see will it be able to carry the load, will it be able to, electrical load, will it also be able to carry the fault levels, and simulate different conditions and see if it will really be able to stand the test of time. Yeah. Look, in the world we're living in now, we're relatively fortunate because we're able to simulate almost everything that before it gets built. So one thing that is critical is to ensure that there is capacity to simulate your infrastructure before you even get to build it. And secondly, you need to be able to analyze. But the biggest thing is to make sure that the selection of parameters they give sustainability to your design system. And without that, then you tend to not maximize your return on investment, because these infrastructure, they cost a lot of money. So at times, it depends what type of infrastructure you're putting up. If you look at typically your substations, you find equipment that houses both the functionality of an isolator and that of a circuit breaker. And what is good about that is basically minimizes your downtime. Secondly, it also minimizes the required space to put up your infrastructure, because space also costs money, especially if it's owned not by the municipality or by the utility. When it needs to be bought, it might cost a lot of money. So it's making sure that the equipment that we select increases the availability, it reduces the footprint of the infrastructure, and also it's sustainable in terms of spare components. And the last thing that you would also look into is, ideally you would want a piece of equipment that has got minimal number of moving parts, because that will improve your lifespan of the equipment, which basically improves the availability of your infrastructure. If you've got, for example, 2 pieces of equipment, you, relatively speaking, you are saying you are having probably, let's say for a hypothetical situation, you're basically having 2 components that are moving, because you have to switch with your circuit breaker, with your isolator. Again, there is a moving part there. But in terms of a combined piece of equipment, you relatively reduce that to say half, and the number of moving parts has been reduced. So it kind of gives an improvement on your lifespan as well. It also improves your footprint. I think the biggest challenge is on interpretation of simulation results, because one can easily be deceived that if something has been simulated, whatever that comes out of the simulation is the correct thing, which is quite not true. The biggest thing is that you need to be able to translate and give meaning to the numbers that you get out of your simulation system. If the numbers are really not projecting a sustainability of that infrastructure, you need to know what needs to be done, where to change, what components or what parameters do you need to increase, and that then becomes. So I think in South Africa, probably even in the whole world, the biggest challenge is to make sure that the experienced engineers are kept in the loop, to make sure that they train the up-and-coming engineers such that their experience is of good quality, and their judgment is also of that will be able to create sustainable solutions. The reality of the matter that probably we need to appreciate is that the capital lay of infrastructure is very expensive. It's relatively expensive. And if the capital cannot be recovered, it becomes difficult to basically maintain the infrastructure. So again, having said that, there is also a cost that is associated with running the infrastructure. So smart infrastructure, or let me say even smart metering, it gives the capability of kind of reducing the mankind involvement in terms of actual operation or even maintenance of the system. One is able to probably look into the system. One person can be able to look into a system that could have required maybe 4 or 5 people to do that particular work. So with that, in as much as the capital laid down can be relatively high, but looking at the long run, that is justifiable. But in addition to that, we've got also, especially looking at the metering, we've got the concept of split metering, which will basically look, or rather take into account, the issue of revenue protection, which will talk to the return on investment. Because without revenue protection, it becomes really difficult to further develop the infrastructure, because there wouldn't be enough revenue collected such that it results into procurement of the next phase, or rather to develop further whatever that has been built at that particular point. Ideally, you would want a consumer to basically be on a prepaid system, whereby you are able to disconnect someone who hasn't paid for the service that is receiving. But the biggest thing, or rather the convenience that comes with smart metering and the split metering, is that it's observed when you have to reconnect the person. You can be able, with the smart meters, to reconnect the person remotely. You don't necessarily have to be physically where the unit that was disconnected is. So it gives convenience that once the service has been paid for, you can relatively immediately reconnect the person. And it also avoids the direct confrontation between the service provider or the representative of the utility and the consumer. So it will be a matter of sitting remotely and reconnect the service, the consumer, and the consumer will be relatively happy, or rather will be relieved that the power is back. But without the smart metering, that is relatively impossible. But the split again, it kinds of also improve, or rather it makes it possible that the municipality or the utility have his operation point outside the consumer point of consumption. So in as much as it's a one system, in a sense that your split metering is one system, but one portion of your meter is inside the consumer point, and the other one is in the vicinity of the service provider or the utility. It makes it also viable to operate or to manage the consumption or the distribution without having to physically come into contact with the actual consumer. I think the biggest win is that almost everything can be observed and controlled remotely. But then in terms of the functionality, it depends on the configuration. So it also gives the ability to grow the functionality. So you might find that the capital that is available now is just suffice to have a meter that will show basic components or basic parameters. But then as the capital becomes available, it's easy to further grow the functionality of that particular meter. Whereas before, you might find that you'll have to change the physical meter itself, but in this case, you wouldn't be actually required to do that. It's a matter of just putting more blocks in order to get more information out, or to be able to send more information to the meter itself. It goes without saying, large power users, they consume a lot of power. And they, by nature, they would prefer to have a high return on investment through keeping their equipment for a very long time. But the reality is that the way technology changes is such that every time you get an improved piece of equipment, that translates to an improved consumption as well. And so, for example, if you look at your power factor correction, which make use of capacitors, the type of oil that was used before is no longer allowed in other countries, even in our country, to be in these days. So the biggest thing is that the engineers need to keep abreast with the laws and the compliance issues for the type of equipment that is on their side. Also, in terms of predictive maintenance, it will be good that you have equipment that is able to communicate with the latest technology, because without that, you will lack that component of predictive maintenance, and you might find yourself wanting every time with unplanned shutdowns. And lastly, in large power users, you find that maybe you've got big equipment like your rectifiers, your cyclones, and all of those, they tend to generate harmonics. And that will have bad impact on your electronic components within your plant. But the worst thing is to feed those impurities back to the point of common coupling, because that might have also impact on your neighbor factories, which might result on huge penalties on your company. So it's very important that to regularly check your quality of power supply to make sure that you don't feed impurities to the system, also to make sure that you don't receive power that has been infiltrated with harmonics especially. And lastly, you would want to understand that there are equipment like your motors, your transformers, which will make use of reactive power to operate. And which is the power that really you cannot say it's not required, because for them to function, they need that. But what is important is that you are able to change the source of that power from the utility through providing your capacitor power banks, your capacitor banks in your plant, which is basically, technically speaking, you are providing, or rather you are supplying your reactive power from within rather than to pay for that power from the utility. So in that way, it creates more room for your feeders for your feeders to have more capacity. Thus, you can be able to make use of your real power for more components rather than for the few. And you also get benefits for that on your bottom line. That can also reflect. You get less penalized by your utility, especially in our country. If your power factor is 0.96 and less, you don't get penalized. But if it's below that, you get penalized, and your consumption basically is not efficient in that way. Probably I would say it's explored more now than before, simply because we've realized that we've got more energy that gets dissipated into environment. However, that could have been used to generate electricity and reduce our bill.
Can you give an example?
Okay. Typically, if we look at, for example, a medical waste area, you find that they will be burning the medical waste, but the energy that comes out of that process is basically released into the environment, so it becomes wasted. But with the technology nowadays, you can be able, instead of basically just releasing the energy into the environment, you convert that energy into useful electricity, and in that way you technically reduce your consumption from the utility because of the electricity that you have generated. So you basically have two forms of generations that fits your plant. Is the one that you would have thrown out, and the conventional one. It's possible, but you have to engage the utility and make sure that the quality of power supply is of satisfactory requirements to them. And also sometimes the issue of stock feed may become a problem if you have put it such that you have guaranteed that you will have that power generated to the grid at agreed intervals. So it's quite a possible solution, because what it happens is that what it helps with is that you basically share that electricity, that energy that you have generated with anyone who needs it, because people get to access energy from the grid. So if it's just within you, it's just you that can be able to use it. So with the peak demands, you will be able to contribute positively rather than to have it just by yourself. In most buildings, the key culprit is your HVAC, which is your heat and ventilation system. If it's not, if it's let me say, if it's not efficient, you'll find a lot of energy going into your, in a layman's term, your air conditions. The second culprit will be the power that is burnt by your lighting. With in our days now, we've got efficient energy savings bulbs, which probably a 5 watt will give you an equivalent of maybe a 20 watt bulb. So you're burning less energy than what you would have burnt. So one bulb, one old technology bulb will be able to will be consuming in a power that is equivalent to 4 bulbs. So again, that's a lot of saving. If also you look into the type of the lifts that you use, that's another area as well that will have an impact on your. And lastly, water heating is also another culprit. If you have a better controlled system in as far as your water heating is concerned, especially if you look in areas like your hotels and the stuff, if your geysers are set on high temperature, it becomes a problem because you find that it heats up, but then a person still has to put cold water to cool it down. So it's really becomes an efficient system. The critical thing is, as engineers, we need to take into account the contractual terms and conditions. Whatever that we do should be done in the ambience of the contract. But having said that, the next biggest reality is that since the world has become the global village, engineers have to be very alert in the type of equipment that land to site. In fact, on the stage whereby an engineer is speccing his equipment, he needs to refer, make reference of reputable test types, that test laboratories that needs to be that the equipment needs to be tested in. It also needs to refer the equipment manufacturing to certain specifications that are well acceptable, especially if we're looking at our case, we've got SANS standards as well as we've got other international standards. So the equipment has to conform to agreed standards, as well as the installation, because that also can compromise the functionality. The installation should be performed as per the agreed methodology, in a sense that methodology will cover things like how do you transport your actual piece of equipment, because that has got an impact in the functionality as well. It looks to how tight should you, when you mount your equipment, how tight should you make your bolts in terms of torquing. It also looks into what type of surface coating that you need to apply for equipment, because that also has got an impact. It could have an impact in terms of reacting with gases around the area, depending if it's in, especially if it's in a plant, it could react to some gases and then find that your equipment gets to corrode before time. So we need really to make sure that we check the compliance to the standard, we check the tests facilities that the type test has been conducted in. We also would have to make sure that we insist on holding points that we would have put, especially where routine test has to take place for different equipment. The biggest thing from my perspective is if we can have an agreed standard in terms of, for example, voltage levels, as well as the type of equipment that is acceptable in different parts of the world. And also, the other thing that is also important is if we can have power purchase agreement in place before the whole project is executed. The reason I'm saying that is because at the end of the day, you would want your return on investment. So if the power purchase agreements are not in place, you might find that you've got capacity in a particular area that is not really consumed by anyone. Thus, no one will be able to pay for that thing. So with common standards and common engineering practices, agreed engineering practices, because common is also relative. It could be common in South Africa, but in another country that their common standard is something else. So it's more of agreed standards that needs to be in place, agreed as well as operational issues, and making sure that there is adequate skills transfer in between the countries. Yeah.